Find the area of a triangular vegetable garden with sides. Oh, okay. I need to do A, B, and C. One day I'll get a diagram that looks correct. We want to find the area, so hopefully I also wrote out the formula for area. And I've got all of these side lengths, so I have too many side lengths to choose from. Unfortunately, I have no angle, so I need to solve for an angle before I can find the area of a triangle. This is your more common IB question where it'll be like, first solve for angle B, and then you can solve for the area. I think you can go ahead and do this on your own. Let's solve for angle B. Remember, you have a formula for solving for angles. It's in your formula packet. Your formula for solving for angles is the cosine formula, the law of cosines, just isolated for cosine, and it's equal to a squared plus b squared minus c squared all over 2 times a times b. You get that that is 0.8 repeating. So when you use your inverse of that exact value, make sure not to use rounded values. We get that theta is approximately 27.3. So then we can go into our area of our formula and we can solve for the area. Go ahead and tell me what that area is. Make sure you use your exact value in your calculator, not the rounded value of 27.3. We should get that the area is about 41.3 meters squared. Okay, last one. We've got a gazebo, and it's in the shape of a regular octagon. An octagon has 8 sides times 2. I'm terrible at drawing octagons. The idea with octagons, especially regular octagons, is that 8 triangles make an octagon. And not if you're talking about a regular octagon, which means all sides are equal and all angles are equal, then that means that these 8 triangles are all the same size. And so when you're talking about regular polygons, you can break up that polygon into that many number of triangles. And that's the key with these types of problems. That unlocks the problem. That if I find the area of one triangle, so the area of the octagon is equal to 8 times the area of the triangle. If I find the area of one triangle, then I can just multiply by 8 and find the area of the floor. It tells me that the side lengths are 1.2, which means that they are all 1.2, which means that if this is the triangle that I moved up here, this guy is 1.2. If all of these angles, boom, 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 if all those angles are the same because they're all the same triangle size, I know that angles around a point add up to 360. So this angle right here, or one of these angles, would just be 360 divided by 8. 8 angles of equal size, 360 divided by 8 is 45 degrees. So that's a 45-degree angle. We also know that with these regular polygons, that the triangles that come out of them are isosceles, that this length is equal to this length in order to make that regular polygon. Because if it was longer, then it would make this side length kind of go like this, and then it wouldn't be a regular octagon anymore. It would be a different type of octagon. So now that we have all of that information, we know that in order to find the area of a triangle, we have to do 1/2 AB sine of C. And I'm going to take stock of what I have. I've got one side length and one angle, which means I need to solve for another side length. In order to solve for another side length, let's see if you can figure out on your own how to solve for a side length. Go ahead and solve for this side length right here. We can go ahead and start brainstorming of how am I going to solve for that side length? Well, it's a non-right triangle. Non-right triangles means it either has to be law of sines or law of cosines. I know that these both are the same, so kind of like our isosceles triangle up above. So we could set up law of cosines and we would have like an x squared and an x situation, or we could try and set up law of sines, but we know that we need to find out more about these angles, which we can. We know also that this angle and this angle are equal. I'll do 2 arc marks to show that those are equal to each other, which means if I subtract this from 180, I could then divide by 2 and get that this angle is 67.5 degrees, which is the same as that angle. And now I have all the information I need in order to solve. I like using the law of sines more than the law of cosines just because I think the law of cosines is a lot. So I'm going to set that up. And we get that x is approximately 1.57. Remember, because we're talking about trig, it's super important that you keep that exact value and don't round it when you're now using it for your area formula. So now that we have all of that information, you can choose whichever 2 side lengths and the angle between them that you want in order to solve for the area of the triangle. Go ahead and solve for the whole dang thing, not just the area of the triangle, but also the area of the octagon. I like to be able to use this side length and just square it because I've just found it in my calculator. So I'm going to do that because a times b would be x times x, which is just this guy squared, times the sine of the angle in between. The area of the triangle is about 0.869117, something. Multiply that by 8, and we get 6.95 meters squared. Right. This type of problem here is probably the hardest type of problems we deal with in terms of the area of a triangle trigonometry style, where we have to like puzzle out a diagram and figure out, oh, it's just a triangle. And then from there, how do we solve for the parts of the triangle in order to find this area? I explained a lot of it, so hopefully it kind of followed and made sense. But being able to figure it out on your own is the hardest thing, right? So making sure that you give yourself permission to take time with it. It's fast because I already figured it out. But when I first had to figure it out, it took time and it took mistakes, and it just takes puzzling pieces together. So great job today, and just remember to approach your puzzles with grit.